You can't directly create an instance of an abstract class. You can only create an instance of a class that derives from it. And when you create the abstract class, use the abstract keyword in order to identify it, to define it as an abstract class. Now, an abstract class can contain abstract properties and methods. If it does, derived classes cannot call those properties from the abstract class. The derived classes have to implement them entirely on their own. And you use the abstract keyword to identify a class member as abstract as well. So let's take a look at some code to see how this is all implemented. Here's some code that creates a completely abstract version of the customer class. So this is a completely abstract class with abstract properties and methods. And so the class itself has the abstract keyword as well as all of the members within the class. Now, by the way, there's nothing magical about using the word abstract in the class name. I've just done that here to distinguish this from the customer class that I've been working with in other parts of the course. But the name of the class has nothing to do whether it's abstract or not. Only the use of the abstract keyword does that. Okay, so I have constructors, but notice that there's no implementation to the constructors. So I have 3 constructors, just like the original customer class. And here are the properties. They're all abstract. Notice that there's no implementation whatsoever. There's no code that reads and writes to base classes. They're not automatic properties, nothing, because all I'm including is the declaration of the properties and methods. So that's important to understand that. And then down here, I have various methods of the abstract customer class. All, again, have the abstract keyword. They're all public and void or return different data types. And it defines the name of the method and the parameters it receives. So I can still define overloaded methods. I can have multiple methods of, say, getCustomerInfo, if that makes sense for my class. And they can all be abstract. They just have to provide different parameter lists, numbers of parameters or types or whatever. All right, and go down and you can see that it implements all of the different methods of the customer class, but it's abstract and has no implementation. All right, so to really emphasize the point, the most important thing about this class is that it contains absolutely no implementation code whatsoever. It's nothing more than an empty template that tells you what constructors, properties, and methods that a customer class, a class that derives from this class, should have. It includes member names and parameter lists, but no code that actually executes and does anything at all. All right, so we have this abstract class. Another interesting thing about it is that we can't directly instantiate this class. So if I come over here to the code within my program.cs file, and I remove that comment, what this code is doing is it's attempting to directly instantiate that class. So I'm newing up abstract customer and going to assign it a reference to ABST customer. But as you can see, this code isn't going to compile. And if I hover over this, it says you cannot create an instance of the abstract class or interface abstract customer. Okay? So this specific message is appearing because I declared the class as abstract. Now, in this particular case, all of the members of this abstract class are also abstract, but that doesn't necessarily need to be the case. So I could leave off the abstract keyword here. The class is no longer abstract. I could now instantiate it, but if I were to do that, I would have to provide implementations for all of the abstract members. Okay, so I'm going to comment that back out because that code's not going to compile if I leave it like that. All right, so how do we use this class? What I'm going to do is I'm going to come over here to Solution Explorer, right-click, add a class, and I'm going to create a derived class from that abstract class. So I'm going to call this Customer A for Customer Abstract Implementation, something like that. Add that. And there's my new class. And the first thing I want to do is say that this derives from that abstract class. So I'll hit colon and start typing abstract customer, and there you can see that I have the abstract customer class that I was just showing you. Okay, so this colon notation or syntax tells the C# compiler that customer A is a class that derives from the abstract customer class. Now, notice that I immediately get a red squiggly underneath customer A, the name of the class. And if I hover over it, I get this kind of a mess here. So, and what it is basically, I have a number of errors right now in my code. Customer A does not implement inherited abstract member abstract customer.region. It doesn't implement abstract customer.customerSense, customer ID, update location of this particular, that particular parameter list, and on and on and on and on. So I have a number of errors in my code. If I come over here into the error list, if I can open it, I get all of those same errors and I can examine those. So what this is saying is that I'm inheriting from an abstract class. In this case, the class is abstract and it has abstract members. The entire class is completely abstract. So this is kind of the extreme situation. So I have all these errors because in order to derive from that abstract class, I have to provide the implementations of all of those methods. The compiler doesn't let me get away with missing any of them. Now, I can do very simple implementations. If there's any methods that just don't make sense, well, to implement for this drive class, well, that kind of raises the issue that either the design of my abstract class is probably lacking or how I'm trying to use it is probably lacking. But if there's the odd outlier, there's one or two methods that for this particular drive class I really don't need, then I still need to provide an implementation. The implementation might just throw an exception saying some sort of a appropriate exception object that indicates that you can't use this exception. In fact, the not implemented exception would probably be the ideal one. But otherwise, before I can compile this code, I have to provide implementations of some sort for every single one of those members. Okay, but all of these error messages boil down to just one single problem. Because abstract customer is an abstract class, and because customer A is inheriting from it, you have to implement all of the abstract members of abstract customer. Okay, so that might seem like it's a bit overwhelming. Well, and in a way it is, because abstract customer has a lot of members. This is a fairly comprehensive customer class. Real world customer probably is still not a full implementation, but well, it's definitely not. Definitely doesn't contain all the data that you'd probably want to save about a customer. But even this stripped down version has a lot of members, and you have to implement them all in order to even compile this code. Okay, but the good news is that if I select that, I have the little quick action light bulb there, and I click on that, and notice that it gives me this option to implement the abstract class. And if I come over here and select that, notice that I get different options. So when I select the customer A, the name there, the reason I only got one option in the quick actions is because there's really only one solution at this class level, and that's to implement all of the members of that abstract class. So I can select this implement abstract class, and that's the one I'm going to do in just a moment. But the ones that are over here for abstract customer, if I select that here, it now gives me the option of generating the constructors for the abstract customer class. Now, the constructors themselves, if I come back over here, are not strictly speaking abstract. I still need to provide an implementation, but that's all part of making the class abstract. Okay, so I get different options. What I actually want to do is select the customer name there and select implement abstract class. Now, This is a really nice feature of Visual Studio 2015, where if I hover over the option, I can see a preview of what's going to happen when I select that option. And I can scroll down and I can see, gosh, yeah, I'm getting all of those different members, and I can look at what's going to happen to my code. And as you can see, they're all going to be implemented with this throw new not implemented exception. So I still need to write the code for each member, but at least I have the template for all of those items. Okay, so I'm going to go ahead and click on that, and that actually puts the code here within my class. All right, so at this point, Visual Studio has fleshed out the member definitions that are needed in the class to fully implement the abstract class. Notice that, in fact, it's a little bit clearer if I move off of it, there's no longer a red squiggly underneath Customer A because I now have fulfilled the contract, the implied contract of saying that I'm deriving from abstract customer, because I have, in fact, implemented all of the required members. Now, this isn't a very useful class to use because anytime I access any of the members, basically, and I pass in any parameters to the members, to the methods, then I'm just going to get an exception back. Okay, so not a terribly useful class at this point. But the point is that now this code is going to compile. And so I can start implementing it. I can implement a couple members, test them, run the application, make sure that the property assignments and the getters and setter methods are working, then start implementing the methods, compile the code, and I can work through and take all the time I need in order to implement this class. But along the way, I can compile it. And in fact, I can write testing code against this, or maybe I have a suite of tests that I've already created if I'm doing test-driven development. And the tests will fail until I fully implement all of these. But I can test and see that I'm whittling down the number of tests that are failing as I'm implementing different parts of this class. Okay, so to fully implement the class, I have to implement each member, remove the throw statements. But the nice thing about the throw statements and raising exceptions is that if there's some member buried deep in here, as I'm scrolling, I miss that I implemented something, I now send this application to the testing server, and testers doing a thorough job can catch that they're getting an exception instead of assigning the customer name property or whatever it is. Okay, so the bottom line is you still need to actually write the code to implement it, but it's a lot simpler because you already have all of the required members there as part of the class. Okay, now one mildly annoying thing about how all of this code was implemented, as how Visual Studio implemented the code, when it implemented the abstract class, is that it places all the members in alphabetical order. So you can see that I have annual sales, city, country, customer ID, customer name, customer since, and then and so forth, and all the members and so forth. So all of the properties and methods are all mixed in together in alphabetical order. And that despite the fact that here in abstract customer, I have the constructors first, and then I have various members, and then properties and so forth. Okay? So it just completely ignored the order of the members within the abstract class and just put them in alphabetical order. Good news is that you can easily rearrange them as part of implementing them. You can put all the stuff that you've implemented at the top, put them, as I generally do, the constructors first, then the properties, then the methods, or whatever order makes sense to you. But that's kind of a mildly annoying thing, particularly if you wrote the abstract class with keeping in mind that you want to put things in a particular order. The derived classes, the code that Visual Studio implement ignores that and puts them in alphabetical order. Okay, so at this point, I'm not going to fully implement Customer A. I'll go ahead and save my work though, so that the application compiles. Now, one thing about this is that the abstract customer class that I showed you here is completely abstract. Abstract keyword on everything in sight other than the constructors, but essentially that, putting the abstract keyword on the class essentially does that. Okay, but in an abstract class, you can choose how much, if any, implementation code to include in the abstract class itself. The abstract class doesn't have to be completely abstract. Okay, so this form has no code whatsoever, no implementation, just the definitions. So that's one choice, but not the only choice. So you could choose to include code and constructors and properties and make only methods abstract. Or mark whatever set of members you wish to be abstract. All or nothing is not the only option. All right, so I have another abstract class here called Abstract Customer 2 that does that. Kind of does a partial implementation. Okay, so the abstract class itself, or the class itself, is still marked as abstract, so I can't directly derive or can't directly instantiate from Abstract Customer 2. Okay, so that's still the case. All right, then I have various backing fields there. I have the empty constructor, but here I'm providing the implementation for this particular constructor. So I've now written the code where I'm taking the parameter value that's passed in and assigning it to the backing field. And I'm also directly saving that customer immediately. Okay, doing the same thing for that constructor, and then implementing the customer ID property and the customer name and the city and the postal code and the region and the country and the default country and annual sales and location. Okay, so there you can see that a lot of the properties I've implemented in this version, but the methods are still abstract. So I have the definitions because I want them to be part of the abstract customer class, Abstract Customer 2 class, but I've not provided the implementation details. So now this is a partially abstract class because I've implemented all of the properties but none of the methods. Even that's not a clear either-or sort of situation. I could implement some of the properties but not others, some of the methods but not others. I could have a single abstract member within this class. I would have to implement it into derived classes. So you have a lot of flexibility in how you actually implement these partially abstract classes. Okay, and so I have a Customer 3 implementation here that, as you can see, inherits from Abstract Customer 2. And so in order to implement and use this derived class, Customer 3, I need to provide implementations. At the very minimum, I have to provide implementations for all of the abstract methods in Abstract Customer 2 that don't have code implementations within the abstract class. Okay, and so that's what this Customer 3 class essentially does. Now, there's nothing really all that interesting in this code because it's really just copying over some of the regular code from the customer class. But notice that it's not even fully implemented. So in this case, I've just left the throw new exceptions, and which I can do. As long as I have an implementation of all of the abstract members, I'm good to go. Customer 3 will compile. I can use it. I'll get exceptions if I try to use any of these methods that I haven't provided implementations for. Okay, the other important thing is that when I created Customer 3, I actually used that light bulb in order to implement all of the abstract members of Customer 2. And what Visual Studio did is it only provided implementations for the abstract members of Abstract Customer 2, not for all of the members. Okay, so if I come back up here, you can see that the properties don't have the abstract keyword. And so when Visual Studio provided the code, it didn't provide any of the implementations of those non-abstract properties. So it's intelligent enough to see that a property was not abstract or a method in a different class was not abstract, doesn't provide an implementation of it because that wasn't an error, that wasn't required in order to derive from Abstract Customer 2. There's already an implementation for those members in the abstract class, and I can override the member in this class, I can do other things, overload it and so forth, but it's not required in order to implement or to derive from abstract customer 2.